You learn more from failure than from success. Don't let it stop you. Failure builds character. Honorable Chief Guest of the Day, Dr. Ashraf, respected dignitaries, guests, delegates, and all the participants. A very good evening to one and all present here. I, Sumaya K. Ashrafuddin, feel privileged to welcome you all to the 72nd talk of the Inter-Society Weekly Webinar Series, jointly organized by the IEEE Kerala Section, the Institution of Engineers India Kerala State Centre, Computer Society of India Trivandrum Chapter, Project Management Institute Kerala Chapter, Internet Society Trivandrum Chapter, Vakam Maulavi Foundation Trust Trivandrum, Life Member Affinity Group IEEE Kerala Section, IEEE Engineering in Medicine and Biology Kerala Chapter, the Institute of Electronics and Telecommunication Engineering. I would like to remind everyone to please fill up the feedback form by the end of the webinar, which will be given in the chat. It will only take a minute to complete the same. The link to the recordings will be sent to the email ID entered in the feedback. Those who want certificates of participation may indicate it in their feedback form. We live in an era of machines that claim to be intelligent in their own ways, often utilizing our own data. The informed humans interacting with these machines are often worried about their privacy and security dimensions. The real implications are much more than the individual concerns, but the industry has to survive addressing the genuine issues. In this context, the way forward is the development of technology and policy frameworks addressing the ethical implications of applying artificial intelligence in real-world problems. Academia, industry, and the governments across the globe are aware of this impending necessity and are taking proactive steps. This talk will shed some light on some of those directions from an artificial intelligence researcher, consultant's perspective. It's time we begin the event. I invite Aishwarya from IEEE for the welcome speech.
Thank you, Sumaya. Am I audible?
Yes, Aishwarya, you're audible.
Okay. The only way to discover the limits of the possible is to go beyond them into the impossible. Good evening, ladies and gentlemen. With utmost pleasure, I welcome you all to the 72nd talk of the Inter-Society Weekly Webinar Series. Today, I'm highly honored to welcome Dr. Ashraf S., Dean of the Digital University Kerala, founder and professor in charge at the Kerala Blockchain Academy, to share his insights on the topic, Ethics in AI, a Practitioner's Perspective. Welcome, sir. Now, I would like to welcome AG Harindra Lal, sir of IEEE, for successfully conducting the previous 71 webinar series. Welcome, sir. I would also like to welcome our MC for the day, Ms. Sumaya, our Zoom master, Ms. Afnan Shihab, and Ms. Sandra, introduction to the speaker, and lastly, Ms. Jifty for delivering the vote of thanks. Welcome, team. Lastly, I wholeheartedly welcome all the dignitaries and participants attending this webinar. Once again, I welcome you all, wishing a productive and wonderful evening ahead.
Thank you, Aishwarya. Now, I invite Sandra Baiju Edge from IEEE to introduce our speaker.
1 minute, Sumaya. 1
Yes,
minute. I shall interrupt. Yeah. Good evening to you all. I am Harindra Lal. Today, we are honored with the presence of a distinguished personality from IEEE, Professor Saifur Rahman, former International Power and Energy Society President during 2018 and 19. He is a life fellow of IEEE. He has made a presentation here last year, the 15th talk of Inter-Society Weekly Webinar Series held on 22nd July 2020 on global electric power sector engaging with environmental issues. The due apologies to the non-IEEE members, I take some time from you to honor this august personality. He is a founding director of Advanced Research Institute at Virginia Tech University and Joseph Loring Professor and Director, the Bradley Department of Electrical and Computer Engineering there. He is a founder of BEM Controls LLC USA. He has strong linkage with India academically, with public and private sectors, and strong family connections in West Bengal. He has conducted a few India government-sponsored GIAN programs, Global Initiative of Academic Networks, in higher education aimed at tapping the talent pool of scientists and entrepreneurs internationally to encourage their engagement with the Institute of Higher Education in India. He has participated in joint research programs in several leading several leading universities in Kerala of India. As the PES president, he started IEEE PES Corporate Engagement Program in India in 2018. Bengaluru Electric Service Company BESCOM and Schneider Electric India have joined the program, and several other public and private sector companies are in the pipeline. In this connection, I might add that he is contesting for the IEEE President-elect for 2022. I have a fervent appeal to the IEEE members present here to support his candidature and exercise your franchise in his favor and spread the news to your IEEE friends and colleagues. Professor Saifur Rahman, wishing you all the best in the coming election and your professional career. Please take care of your health too. Thank you all. So now we start the regular program. Sorry for the interruptions.
Yes, sir. Thank you very much. Thank you very much for the introduction, sir. Now I invite Sandra Baiju Edge from IEEE to introduce our speaker.
Sandra, are you there? Sumaya?
Yes, sir.
Yeah, you can just introduce the speaker and go ahead.
Okay, yes.
No problem, Sandra.
Yes, sir. Just a minute, sir. Sorry for the delay. Dr. Ashraf S. is the Dean, Research and Development of the Digital University Kerala and the founder and professor in charge at Kerala Blockchain Academy. He was the founding professor in charge of Maker Village, Cochin, India's largest IoT incubator. He received his PhD and Master of Engineering degrees in Computer Science from Indian Institute of Science, IISc, Bangalore. After his PhD, he has worked with America Online and IIM Kozhikode. He is a recipient of several IBM awards, Bill and Melinda Gates Foundation grant, and US State IVLP Fellowship. He has published 3 books and more than 50 research papers in international journals and conferences. His areas of interest include technologies and business models related to machine learning, data engineering, and blockchain. It's time we welcome our chief guest, Dr. Ashraf, to enlighten us through his knowledgeable words. Sir, please take over.
Thank you for the generous introduction. I hope I can share my screen. Hope my screen is visible. And welcome to the session on AI ethics. I'll be talking from a practitioner's perspective because it's a topic which is discussed at length at multiple dimensions. And my perspective would be more from my practitioner's researcher's angle, and I'll make it more of policy-driven and opportunity-driven rather than making it very technical. And I plan to speak for another 35 minutes, max 40 minutes, and followed by a Q&A. That's the way in which this is planned. And thank you very much for this opportunity. Good to interact with the distinguished panels and attendees over here. So let's start with a very brief intro to the context of AI today. AI, artificial intelligence, is a term that's coined by Professor McCarthy back in 1956 in Dartmouth Conference. And it's a science of making intelligent machines, as we understand. Can we mimic the intelligent behavior of living beings is what AI is all about. And we started this journey way back on representing data in a more or less in a rule-based fashion using logic. And we call those systems the expert systems. And now we live in an era of discovery, of automation of discovery, which we call as machine learning. It's nothing but primarily, can the machines figure out, or can we build algorithms that can figure out knowledge from available context, which can be historical data, which can be the context in which the model is, the algorithm is sitting, or it can even be experience based. So we have moved from the era of knowledge represented in terms of expressions in a symbolic way to an era where automation of this knowledge discovery is happening. That's called the machine learning based AI. That's where we are in, and there are many definitions and research publications around what is meant by AI. Let's not delve into it. What it says is, the bottom line is, it's all about building systems which can do smart things, intelligent things, or mimic the behavior of living beings. That's where we are. And if you look at or hear from the famous author Pedro Domingo, it's a 2015 book from him, from University of Washington. His book's name is The Master Algorithm. There are 5 megatrends that's happening in the AI context today when it comes to leveraging data and building knowledge. The primary one being we are in an era of transition from computers that are programmed by us to computers that learn in their own way. So the symbolic data or knowledge driven approach to automation of discovery process of knowledge. That's what the machine learning based context. That's one trend that's being seen. The other trend being automation of scientific discovery. We know that we can build algorithms that can find new drugs, new ways of looking at fraud, new ways of scoring people against people on different dimensions, either the credit worthiness to potential to a disease. I mean, basically like amenable to a particular context, or the extent to which they are susceptible to a disease. So you can do automation of scientific discovery. That's another mega trend. It's in the AI world when it comes to data-driven AI. And the third, probably the most, one of the most important dimensions that everybody is worried about today is we are automating jobs. And one of my friends was saying a couple of years ago, right, hundreds of computers may replace millions of jobs. So it's not just blue collar jobs, which is more or less automatable by a robotic process automation. We are living in an era of cognitive robotic process automation. The machine can figure out how a program's being structured, and if you can generalize beyond, you can find out patterns beyond that. You can even automate the art of writing a program. So even a white collar jobs, or even the job of disseminating knowledge at some point in time will become automatable. So anything which to have a repeatable context can be automated. That's where it is. So it's more of cognitive robotic process automation. And the fourth trend being, we are moving from a deterministic world to a probabilistic world. We live in the era of soft computing. We live in an era where deep neural networks or a fuzzy-based reasoning systems, which even controls our cars, or even our washing machines, right? That's happening from a deterministic world to a probabilistic world. And the fifth trend is more or less dangerous from a societal perspective. This is everybody is moving towards evidence-based decision making. So is politics. We live in an era of computational politics, and everyone talks about data-driven intelligence and decision making based on that. And data, it's only like data only reveals what you've collected so far, and there is a lot of unknowns around it, and your models are built around what is known. So that's a dangerous part of it, the rise of evidence-based decision making. So these are 5 mega trends in which AI being applied, AI being leveraged, and what is it leading to, all right? And how does this learning process, the automation of discovery happening? And again, going by the terms that Pedro defines in his book by the master algorithm, there are primarily 5 tribes in the discovery process. That's basically the automated knowledge discovery process, which we call as machine learning. The 5 tribes or 5 categories are symbolist way of doing things, which is all about our logic. Primarily, can we symbolize things and can infer from that? And then comes the connectionist world, which is more about mimicking a brain or neural networks and things of that kind, connected systems, and then primarily like connected network of nodes, and can we learn weights connecting nodes, and can we infer things from there. Then comes mimicking the genetic process of evolution, the evolutionist models, and then the 4th one being Bayesian approach, which is more of probabilistic in nature. Can evidence strengthen your belief on something, right? You see more evidences in a context. Can you say that I know more about the context, and I do have more what you call believability in the context? That's what the Bayesian, the probabilistic inference is all about. And the fifth tribe or category of knowledge discovery algorithms is called analogizers, which is the simplest being the nearest neighbor. So can I say like, okay, since you have bought books of this kind, your friends have bought, or your collaborators, or those who are similar to you have bought books of this kind, you may be also interested in this book. This is called what Amazon celebrated, which is called collaborative filtering, or the nearest neighbor context, or nearest nearest instance-based approaches. That's called the analogizers. You are similar to the other one, and so you must be following that category. That's the 5th category. And if you look at these algorithms, there are master algorithms in each of these contexts. For example, in the symbolist world, the knowledge-driven world, you have inverse detection algorithms and logic, primarily around logic. Origins are from logic and philosophy. Then comes connectionist. You have models of the kind. The celebrated backpropagation algorithm, which functions as the foundation for anything from a simple feed-forward neural network to deep learning algorithms. So that's where the connectionist kind of class lies. And then comes evolutionist models. We have celebrated algorithms of the kind, genetic programming or genetic algorithms, and Bayesian, we have probabilistic inference, or even a Bayes way of handling things, Bayesian reasoning. Then comes analogizers, algorithms like kernel machines or supported machines falls in this category. So all I want to say is the AI has grown from the world of symbolist logic, probably the most closer one to the mathematical logic world, to a world of deep networks or deep learning algorithms or deep neural networks, where we build complicated network structures and learn their weights, right? That's where and we can more or less categorize, we can bucket most of these algorithms into probably around 5 categories, and we are able to achieve or rather leverage these kind of algorithms in many a practical context, and we are happy with the performance being observed out there. That's where we stand today. All right, that's one side of the game. Basically, AI is progressing from the conventional rule-based context to the deep architecture, neural network architecture-based context, and we are all worried about how it performs and things of that kind. The other side of the game is concerns, right? People are like people of the kind, Steve or Bill Gates, have come out with concerns and say like, hey, AI this way may not work, may not be good for humanity in the long run. And you as practitioners or building or researchers or academicians or businesses building AI systems, you have to worry because there are concerns that we need to address, right? I think we should be very careful about artificial intelligence, what Elon Musk says. And people are no different even from the Apple. You can see that eventually they will think faster than us, and I'll get rid of the slow humans, is what says like Bosniak things. So that's what there are concerns around that. And do we as practitioners or businesses or even academicians or researchers have to worry about this context is my talk about. All right, let's look at a few ground realities. First one being the ethical dimension. All right, we know that a robot on a CRM role treated a human like a gorilla. Right? This is something that has happened in front of us. A pharma company is hiking prices based on granular consumption data. Right? This is also happening. social platforms using robot-generated data for promoting lies and damn lies is happening in front of us. When it comes to security and privacy, your mobile device knows more about you than probably what you know about yourself, right? That's where it is. And models which are sitting either at the cloud or at the edge can actually predict what you'll be like doing next, and probably like even predictive actions on your behalf is possible, and that's what's happening. That's where we are in. All digital footprints are machine read, or at data layer initiatives of digital native, seemingly free services is a reality. All right. And that's primarily about the systemic context. And coming to the socio context, we have robotic cognitive process automations, and the future of jobs is or skills are changing, and how does it affect humanity? So these are the concerns, some of the concerns of the realities that are staring us. And as practitioners, do we have to worry about these dimensions? And that's the question that we need to probably address in this maybe like next 20 minutes or so. All right, who could be an actor, a bad actor in the AI context? It can be anybody. It can be military or governments or corporates or even psychopaths or criminals. Anybody who builds AI and deploys AI can be a potential bad actor. Right? So how can AI, and the current perception of AI is more of a black box. And when we build solutions, when we build and deploy solutions using AI as one of the components, right, with that automation of discovery as a part of the process, we need to worry on the technology front primarily on 3 dimensions. One is the transparency of the model, right? You build a model, all right, and when you have built a model, you should be able to understand the working of the model. You should be able to say like, hey, this particular what do you call a model that I've built is actually ranking or primarily giving a number for me, represent the credit worthiness of a customer based on this dimension. This is how the decision is taken. So the understanding of the AI decision making process is one concern. The other concern is like, given a particular individual and you have taken a decision saying like, okay, this we cannot give what do you call credit card to this customer, or this particular person is potentially having this kind of a disease. You should be able to, at an instance, you should be able to explain the decisions, understanding the reason behind each decision. This is more about the right to explanation. And then comes the third dimension. Can you mathematically prove that, right, with the same conditions in place, it's provable that this is what the decision is, right? Can we attempt those dimensions? And whatever be the context, when we build and deploy an AI, building trust is the key, and key for not just adoption, key even for survival. That's a statement that I want to make here. And how do we, and what are the ways in which dangerous things can get into an AI box? There can be like multiple dimensions. One can be a deliberate action, somebody who with an intent creates an AI, and which with a purposefully what do you call selects data, selects algorithms, or selects a process or deployment models in such a way that you actually like the decision-making process is potentially not believable, right? Trustworthy. The second is more of side effect. Some bug may have created, and proper testing may not have what happened. It can be a poor design. The third being what do you call the environment. You're actually like design the system in a context of a particular probably country, and you reposition that in another context where some of your assumptions on the model or even the data may not what do you call hold good, and you can go wrong. And the fourth being more of what do you call, I would say a little more dangerous dimension than the second and the third one. Which is called a runaway or an emergent phenomena, meaning over time a boat becomes a racist is an example for a treacherous term, right? This is also possible. So this is basically an emergent phenomenon out of over time it learns, and then it learns the wrong things or learns to do the wrong things is an emergent phenomenon. So this can also happen. Among all these, deliberate is the most difficult things to address, all right? And how do we address this? Right, one of the primary what you call means to address this is having the right set of regulations. And I've done a survey of all the literature out there, and I could make out that there are more than 30, I think 30 or 32 countries or more than that, where there is an AI strategy for that country to exist, right? There are 30 plus countries over which there is an AI strategy exists. Strategy for adopting AI do exist, and probably another 20 plus countries or more than close to 25, 30 countries where an AI strategy is being worked out. And all these AI related regulations, one of the primary concern is a responsible AI. At a global picture, I've just listed out a few, like European Union has ethics guidelines for trustworthy AI released by the high-level expert group, and likewise Singapore has model governance framework, USA has, and likewise. This is not an exhaustive list, just a representative list that I've taken, right? So more than maybe like close to 50 countries are on the verge of having what do you call it, talking about a responsible AI, which means that regulations are coming out mandating that you need to be responsible and being ethical, or AI ethics is more about the moral principles or values, and responsible meaning you should be ready to apply or respect those values to build a responsible context. All right. And what is happening in the Indian context? Indian context is we had this national strategy for artificial intelligence published by NITI Aayog in June 2018, and very recently, I would say February 2021, the NITI Aayog again come out with a report, a proposal on principles for responsible AI, and it talks about primarily 7 dimensions. Right, I'll go to each of these dimensions in detail, and let us discuss how this affects the practitioners or business perspective. All right, and these are principles talking about what are those guiding moral principles which will potentially take us to an application context of responsible AI, and the actual implementation plan or that suggestion is yet to come from NITI Aayog, and it was expected in somewhere in August or September, maybe in another month's time, we would have that implementation plan also. Let us look at the principles behind the published NITI Aayog report. The first principle, they're talking about the principle of safety and reliability. Right, safety is an interesting concept. Say somebody's data being or a model, from a model, if you can make out that this particular data of this particular person is being used to train this model on a trained model, which is possible as of today, which is basically, okay, somebody's medical data is being being used, and then you train a model, and likewise you have aggregated data and you have built a model, right? Safety concern is primarily you have built a model, and then whether you are susceptible to disease is actually decided by a model. And then you figure out that the model is actually not using your medical data, rather your financial or your I mean, it's looking at your wallet and deciding that you're potentially having this disease to drive you to a hospital or a medical system, right? This is a potential safety concern. Primarily, when you build a model, how do you make sure that it's actually looking at the kind of things it should be looking at to take a decision? That's what primarily the safety dimension is all about. And reliability, as we know, like the classic definition of reliability, you should have a reliable system being built using AI. And the safety and reliability concerns are more of a systemic consideration. What it says is understanding AI system functioning for safe and reliable deployment. So a system which is looking at your wallet rather than your medical data to say that you have this disease is not a trustworthy system, from at least from a safety perspective. And you can't rely on its prediction, because over time you do have an emergent behavior where you will identify all people with probably some contextual data which may not be relevant in the medical context, and ultimately it decides that yes, such people have to be tagged like this. These things can happen, and when you build the model, you should be very careful about it. That's for the first principle. And the second principle is principle of equality. This is connected. All AI systems must treat individuals under the same circumstances relevant to the decision equally, right? You can actually bias your data. You can say like, hey, I have a data where 99% of the context is talking about a positive case or negative case or whatever. I can actually bring in an unbalanced data, train my model in such a way that my precision or my accuracy levels are very high. but I will always bias my decision in some dimension, which is possible even at a data level, right? You can actually do algorithmic selections in such a way that the model being trained doesn't have to, or can violate the principle of equality. You have to worry about that dimension also. The third dimension that you need to worry on the systemic context is principle of inclusivity and non-discrimination. So again, you can actually you can actually train your model in such a way that you are actually, I mean, if certain parameters are met which are beyond the consideration that should be taken for, you can tag them out of a context. And even the NITI Aayog report says that some of our healthcare related insurance policies are designed in such a way that non-discrimination is a mandate, right? So you should train your model, which means that your algorithm selection, your data and your processes should be such a way that AI system should not take incorrect decisions leading to exclusion from access to services or benefits, which is very easy to be built, right? And that behavior itself can be an emergent behavior. We can actually build a system in such a way that over time it will become it can actually violate the principle of non-discrimination. Then comes the principle of privacy and security. This is again a systemic concern. With the current neural network or deep neural networks, there are methods with which if you can get access to the gradients through which these models are trained, or using appropriate perturbation models, you can make out whether a particular person's data is actually used to train a particular of a deployed model, which is possible. You have a black box model, and you can figure out whether somebody's data is actually used to train that model. So, which is possible today. Basically, like, I mean, such a context, such an instance was used, can be figured out. All right, that's more of a privacy concern. I am worried more on a security concern. So, for example, a system trying to figure out, it's more of an emergent behavior over time that, hey, these kind of people on these geographies with these kind of characteristics are susceptible to these kind of attacks, right? It can even be, say, for example, our medical data, you compute that if these kind of people leverage or is having these kind of diseases, and they use these kind of medicines, and they have developed these kind of side effects, and probably that can lead to another disease or whatever, right? You can actually give identify dimensions where the possibility of adversarial attacks can be figured out by an algorithm. So that's more of a security risk than a privacy risk, or an aggregate data even at a personal level. You may be able to the model may be able to figure out or expose security threats. That's the fifth dimension, and the NITI Aayog report says you should not do that. And the principle of transparency, as I've already explained, this is more of basically explaining the model's decision-making process. The report is actually talking about having audit logs and things of that kind to ensure that you have a fair, honest, and impartial guarantees for accountability and transparency. That's what it is. It's more of a systemic concern. And the next concern that the report is talking about is accountability. What is accountability, right? We know that the famous Uber case where Uber taxi, the auto the taxi which was driven by AI go hit, or the vehicle which was driven by AI go hit someone, and then who is responsible for it? And even the the context in which, say, for example, you are building a model for consumption by the world, and when you build the model, there are people who give you the data, there are people who clean the data, there are people who leverage the data for training, there are people who have selected the algorithm, there are people who have implemented the algorithm, there are people who have deployed or rather trained the algorithm and to build a model, and then deployed the algorithm, and there are a hell of activities out there, and the accountability is a genuine concern, because the AI deployment process is a many hands problem. And can we actually treat the AI itself as a legal being accountable for someone is a concern that probably some of the the legal people over here can potentially look into this dimension, because who is accountable for the activity or the action that an AI has taken is a question that we need to worry about. And the last concern, the seventh concern they're talking about is more of a societal consideration, a principle of protection and reinforcement of positive human values. In this context, they are talking about respecting our constitution than societal morality. Basically, constitutional morality should take priority over societal morality, primarily because so societal morality is more of, it can even be a majoritarian decision, but the constitutional morality is a well thought out what we call document and mechanism, and that needs to be respected is what the report talks about. So malicious use of what you call of AI, we have seen in multiple geographies. I don't want to mention, but things of the kind Cambridge Analytica and all that is a reality. And the job loss or reskilling, upskilling opportunity, or can we find new opportunities? Will AI find new opportunities for repositioning our human resource or the next generation of skills, so that we'll be able to create opportunities than losing opportunities, even on a white collar context, is something that we need to worry about. These are the dimensions that the report talks about, and I've already told you. They have come out with the media come out with this report after interviewing a lot of people and then considering various international bodies, consulting international bodies and things of that kind. And then they say like ethics is an emerging field and should be an ongoing research, and they worry about more of constitutional morality over a societal morality when they have created this principle. Basically, case studies in India and the world was considered rights according to the Indian constitution, and the principles were derived out of it. This all fine. So India also do worry about responsible AI, and that's all I wanted to say on multiple dimensions, right? And this is a work by our friend Santosh, who was actually an IAS officer. He was heading the Tamil Nadu e-governance agency. He came out with this scorecard called a VIPMAX Scorecard to assess the readiness of an AI solution. In a context before deployment, you need to identify the diversity, you need to quantify the diversity, equity, fairness, ethics, privacy, data protection, misuse protection, audit transparency, and cross geography. Interestingly, this was proposed in 2020, and the actual media report came out in 2021. So, and they even have a publication on this. So Tamil Nadu has some actionable dimensions where they were talking about we can have a scorecard. Tenega is coming out with it, and he's having a scorecard where any AI application before deployment for the delivery of a service is actually what you call scored against these dimensions, and then they clear it off, right, for deployment or reject it for reasons thereof. Right, that's what the Indian context is. So there are actionables also in the Indian what do you call it? AI responsibility context, right? And then comes the technology. How do we do all this? What are the technologies for responsible AI, or how do we build this? There are multiple initiatives across the globe. One of the primary drivers being DARPA. They talk about what's called explainable AI. And there are other approaches like guaranteeing AI robustness against deception, understanding group. And they are not the only ones. There is Google, Microsoft, and IBM have also received toolkits for responsible AI. They have this what do you call frameworks out there, and things of the kind, Lime, Sharp, and many what do you call technologies were developed by research institutions, and even World Economic Forum has launched a global AI action alliance to accelerate the adoption of trusted AI. So responsible AI and building technologies for responsible AI is also addressed at a global scale. All right, what is the need for explainable AI? Currently, like, we build models which can perform, which can actually do our job, right? And it's being deployed from transportation to military. And when our models are giving us decisions, we are not much worried about the dimensions such as why did you do that? I mean, we can ask the model, why did you do that, and why not something else? When do you succeed and when do you fail? When can I trust you, and how do I correct an error, and things of this kind beyond the performance matrices? But beyond the performance matrices, which is like a precision recall or whatever that we worry about. All right, and one of the most celebrated the technologies of the current era when it comes to the deployment of machine learning is deep learning neural networks. So you have got multi-layered networks trained primarily using backpropagation or variants of algorithms. And then what it does is it can do anywhere from a cat to dog classification to complex, what do you call, adaptive training models, which things of the kind DeepMind uses, or which has succeeded against the Go, the famous player in Go game, the AlphaGo. So basically, we leverage deep neural networks, which is primarily driven as of today by the performance parameters. And then what is explainable AI is primarily around, right, the conventional AI is you have training data, you have learning process, and you build a model, and the model says with some sort of what do you call, it says like, I mean, with some sort of a measure, it says, I know that, I think that is a cat with, and I measure of my measure of, what do you call, I mean, my confidence on this is more of this, right? And the explainable AI talks about, it's not just, I need to say that this is cat. I'm also saying that this is a cat because it has fur, it has whiskers, and it has claws. And I've also seen these features, and that's the reason why I'm saying this is a cat. I understand why I've taken this decision. I understand why not, right? I know when you will succeed and things of that kind. I should be able to go beyond giving you a decision. I should be able to explain why I've taken this decision. If you can build models of this kind, this is what explainable AI is all about. So XAI, we have a lot of models which are all primarily around performance. Tomorrow we may have to, right, if you plot it, we may have to move to a context where we may have to talk about what we call explainability also. The framework would be something like this. You have decisions. Along with that, you will have an interface, an explanation interface, where it will say, yes, I've taken this decision because this is what I see, and from this context, I have concluded that this is a potential score that this person can get. I'm rejecting this application because he is not having these dimensions. Or I can even say, like, if his salary was 5,000 rupees extra than what he gets today, he would have got a credit card. So this is what it is. You can actually give explanations in multiple dimensions, right? So XAI, the XAI dimension, the explainable AI is primarily talking about performance versus explainability, and what I've already mentioned, we are living in an era of deep explanation where we have deep learning networks, but deep explanation is still not a reality. Meaning, deep learning networks which has explainability capability still in the research context. We don't have deployable solutions out there. All right. And the other dimension is, like, can you build, say, for example, if you have a small linear model or a logistic model where you define your logistic regression model on a particular on a set of dimensions or a set of features. Now I know, like, because of these values are appeared in this feature, I can actually, this decision was taken. So we have inherently this what we call explainable model. For example, a decision tree. So we have such models, but they may not be performing as good as a deep learning network. Can we build more what we call models which are interpretable and explainable is another question that we can ask. And the third is, we have already built a lot of models, right? We have got all these black boxes. Can we build mechanisms so that these black boxes can be hit from something else? Can we actually give more data to the black box and find out why these models are behaving like this? Basically, can we actually build what you call explainability on top of available black boxes? That's the third concern that the explainable AI world is exploring. And world over, even at some of the institutions in India, there are research happening on multiple dimensions, right from University of Berkeley to Rutgers. You can see, like, multiple research explorations are happening to build what you call explainable AI systems. And even in India, there are a few IITs and even some of our groups at our institution, we are also getting into the context of explainable AI. All right. And when it comes to explanation, how do you give explanations? Explanation can be a natural language statement. Explanation can be a visualization. I say, like, okay, when you are giving this picture, and since I look at these dimensions of this picture, or these pixels, or these features, I'm saying this is a cat. All right. I can give you a visualization. I can even give a context. Hey, this looks like these kind of things that I've already seen. So which means that, and these things are actually a cat, so which means that this must be a cat, right? Or it can even be alternate choices. I can say, like, if this person was, if this particular, what do you call, the ear was like this would have been more of a dog rather than a cat. Or if this person, what do you call, was having this a little more salary, maybe 5,000 rupees extra, he would have been credit worthy, right? These are called the alternate choices. There are multiple ways in which the explanation models can be modes, or the ways in the explanation can be brought in to the actual decision making context, right? And how do we build explainable AI? There are, you can actually do it at what do you call, three ways. One is, before you actually build the model, pre-building, right? Pre-modeling. Before you actually build the model, you can do an exploratory data analysis and say, like, hey, these features I can actually deciding these things. You can even do a visualization. You can do a visualization with feature mapping, feature reductions, feature extractions, or whatever. And then you build interpretable dimensions of features, and then you build models on top of that. And you can actually choose careful selection of algorithms. Say, for example, if a decision tree does your job, go for it, because, and you can even have good practices for the development processes, right? When you have, say, for example, you have a imbalanced data context, you may have to use something like an active learning, where you respect all the classes which are involved, even when that's a minority class. You make sure that everybody is represented in a proper way in your model, so that you don't get biased to anybody, right? Any concept space. So that's something that you can. So you can have pre-modeling explainability. You can, and the second category is explainable models. There are like intrinsically explainable models, as I said, decision tree or logistic regression is an example. There are models of this kind, or else you can actually use some sort of a feature engineering. So there is research literature talking about you can build explainable features out of known methods, like a, what do you call, a feature selection or extraction, or even feature learning techniques such as neural networks, and then you build what do you call, then you place an intrinsically explainable model on top of it, so that you know what the features are, and now you know the model also, right? How the model works, so we can explain the entire process. That's hybrid models. Then there are frameworks that have come out primarily in the research literature. Some like TED, teaching explanation for decisions. This is a TED. This is, I think, it's a framework from IBM, which is saying along with your model, you can actually along with your decisions, you can actually connect your explanations also. So from your data, you learn a function which gives you the decision and the explanation. So you can actually connect the two, and then you build the model. So basically, like, such frameworks are also there. And the last category is, you already have a model, you have a black box. Can we do a post-modeling explainability? This is called the post-hoc explainability, and most of the explainable AI research is currently available in this. And in this context, you have methods right from, say, for example, instance-based explanations to perturbation. Basically, like, if you have data and you perturb the data and see how the perturbed data or the model responds to the perturbed data, and then you basically build explanations on top of it. Or there are models which can actually there are models which has what do you call, looked at backward propagation, and then like I would say an integral gradient, which Google talks about. So Google's what do you call, the AI cloud, the Google cloud, do have explainability on black boxes using what is called the integral gradients. Basically, it's basically a back propagation context. So there's enough of literature, rich research literature available out here, which is talking about how do we build explainability to the black box context if you already have a model, right? That brings me probably to the last slide of my talk, which is AI ethics, the practitioner's concerns. As practitioners, either as a business or a consultant or even as an academician, we need to worry about the fairness, right? We should make sure that we should avoid bias, meaning bias not just in terms of data or algorithms, even on the development process or the deployment processes. You should make sure that you build models you select data, you build models, and you deploy and train and deploy models in such a way that you avoid bias. And the other concern is explainability. Explainability talks about 3 dimensions, even though the current context, even at the Indian what do you call scenario, they talk only about interpretability, probable transparency, and explainability. But there is a provability dimension also. So if we can build provable algorithms, which is practically possible with many of the machine learning what do you call developments of the current era, can you build provable algorithms? That will be the ultimate goal of explainability. And privacy and security. Privacy, I've already told you, like, I mean, privacy is more of what you call concerns that your mobile data being leveraged. It knows what you talk, in what context you live, and how much you work, and then using that, it's predicting that you are probably going to have this kind of a problem, right? And a lot of such data is leveraged, is utilized from a geography and understanding and predicting. A company is trying to make a prediction that, all right, this is an opportunity, or rather there's an opportunity to introduce a drug with this kind of side effect, so that I'll get an opportunity to sell another drug in another 5 years, is definitely a concern, right? These are some of the what do you call from an ethics angle, from the dimensions of moral values and principles out there. These are some of the concerns that a practitioner has to worry about, and this is being will be mandated very soon by most of the countries which are embracing AI as a technology for solving their problems. And we as academicians or businesses or practitioners or consultants cannot ignore this, because it will be mandated by law, by the regulators very soon. And the survival is to work on work on what do you call understanding these moral principles and values, and then respecting them, so that we'll be able to apply them to build a responsible AI. And that's pretty much from my side. And all I want to conclude is AI. This is Gartner's hype cycle in 2020. We are yet to get the 21 thing. Responsible AI is still at the peak of inflated expectations, but it'll be a reality very soon. And 2 to 5 years is what the Gartner says, as per the what do you call the color from the curve. We can see that 2 to 5 years this will become more of what you call reach, a plateau of productivity. And in the current era, we as practitioners, we need to worry about it. And AI ethics, right, understanding those moral values and principles and applying them for a responsible AI adoption is key to our survival as an industry, as a science which will push humanity in the positive dimensions. And with that note, I would like to open up the floor for any questions that you have. Thank you.
Thank you so much, sir. That was truly a wonderful session. We got to understand and learn a lot from your presentation. So we do have some questions in the chat section from the participants. Can we move on to the question and answering session?
Sure.
Yes, sir. So the first question is, why are these in Indian context only? Or is there anything specific to AI? Any AI ethics specific to India?
No, nothing of that kind. See, that's where I started. I said, like, there are, I mean, at least I've seen 32 countries where there is AI, there is a strategy for AI, and responsible AI becomes a component of that strategy. So it's not specific to India. I just wanted to, my talk was primarily on the dimensions that the media report mentioned, but the concerns are more or less same across the globe. So, and another 20 plus countries where this is being drafted, and then draft form is available. So at least 50 countries do have very similar concerns. So nothing to do with India, and the concerns are more or less global in nature. Yeah, that's my comment.
Thank you, sir. The next question is, use and misuse of the artificial intelligence is possible with time. how the developed AI modules can be tested in the lab, loopholes found out, and corrections implemented. A continual improvement concept is a continual improvement concept realizable? This question was asked by Ravindranath M. Sir.
Good, very interesting question. Basically, when Steve passed away, I just wrote probably a comment in one of the Malayalam, the famous Malayalam newspaper. I mean, my comment was also there among the set of comments they published in the middle of the paper. This was essentially on these lines. What I want to say is, like, we live in an era of AI which learns beyond what we give. Basically, we live in an era of reinforced learning systems where people are even talking about artificial general intelligence. Can you build systems which are doing broader set of jobs than narrow AI? And yes, building an AI and testing that in the lab for compliance on these dimensions and deploying it may not be a wise decision. And that's where the primary is. So, for example, we can build systems which goes far beyond the conventional knowledge-driven trained models. So, for example, RL is all about that. We live. So, for example, our DeepMind, right? DeepMind is talking about deep Q learning algorithm, which is primarily like, I mean, you build on your expertise, and as you go along, you find new strategies of getting better and better. And think of a context where this is being applied in military. That's what Steve's statement was all about. Steven Spielberg. Not the what do you call it? The basically what I want to say is the films have what do you call it, pictured it, and the scientific world is talking about it, and it's basically the moment you bring in reinforcement context to a military, reinforcement technologies to a military context, you are basically like, I mean, you're going to a context where a continued monitoring framework is the only way to go. So a lab test followed by what do you call it? I mean, deployment doesn't seem like a good solution to address this issue. If that's what the question is. All right, because we have gone much beyond what do you call it, mimicking a living being. You can actually go far beyond a given context in the reinforced way. Does that answer my question? Yeah.
Yeah. Yes, sir. There's another question. There are other questions. The next question is: can you throw some light into the latest research or studies on explainability of AI algorithms?
That's what I mean. Yes, continue, please.
Please give some hints or leads on this topic.
Yeah, there are many. That's where I said I've not covered any technology over here. Just look for post hoc explainable AI or post modeling explainable AI. You get at least 50 plus research publications in the very recent past, which is talking about anywhere from a instance-based explainability, explaining a particular why a particular decision was taken, to perturbation-based explainability for black boxes, to frameworks-driven explainability and back propagation-based explainability, decision rule, decision tree-based explainability. So look for, just do a Google search around post hoc, POST-HOC explainability. You get ample literature out there. And the other side, basically building deep explainable models with deep neural explainability is still in the early stages of development.
Sumaya, 1 minute. Sumaya, 1 minute.
Yes, sir.
For our honorable guest from IEEE, he's an IEEE fellow. I introduced him earlier. Would like to ask a question to the speaker in person. Professor Saifur Rahman, please go ahead. You can unmute yourself and speak. Yeah, you can unmute yourself. Jacob, please unmute his phone. Jacob.
Okay, thank you, Professor Ashraf. Interesting talk. When I saw the title yesterday, the day before, AI and ethics. An IEEE senior person, we focus very heavily on ethics of IEEE members, very serious, we take very seriously. I give a lecture at Bangalore, Delhi, and Kolkata, ethics in publishing some years back. So I listened very carefully what you said, and I would like to add to your comment and have a question following that, is the young generation work in IT sometimes are lured into doing something that they don't believe in, but they are hesitant to refuse. This is very important. IEEE member, you can say no to your boss if you think what you're being asked is unethical. I want to have this message widely understood among young generation, that you have a higher standard. Ethics is more than legal obligations.
Sure.
So I hope people in the audience listening and understanding this, and I appreciate you raising the issue very clearly among the audience today. My question is, toward the end, you mentioned reskilling and upskilling in AI. That's my pledge for IEEE election, in fact, reskilling. My question to you is, how do you hope to use AI to help engineers changing jobs, to reskill themselves? They can be more marketable.
Okay, interesting. Okay, that's one of the areas where I've not attempted that in the AI context. Reskilling was one of my agenda when I was setting up the Kerala Blockchain Academy. It's essentially a reskilling opportunity, and we have trained more than 6,000 plus people across the globe today, and that's what it is. It's a 2-year-old avenue. And when it comes to AI, AI is actually opening up a new age opportunity in the data space. And most of this AI, the black box AI at least today, is available in a accessible fashion. Either as a library, meaning, so if you are a practitioner or somebody who is literate in the programming context, you applying or learning and applying a already available framework to find new ways of doing your job, right? This opportunity, because it's more of a skilling than a fundamental dissemination of knowledge, because the AI is more of consumable, is available in a consumable fashion. Then you don't have to know about the principle of probably gradient descent or deep kernel machines or functional functional analysis before you leverage a kernel machine. Because kernel machines, if you know, these kind of libraries do exist, and if you have programming skills, you can learn the right set of tool sets which is available, accessible to you in the open source world. And if you can skill people in those dimensions, what happens is you have productive human resource to do things, and they don't have to say, for example, when it comes to any technology, in the conventional engineering domains, we have people at all levels of detailing, meaning expertise. We have people who actually probably good at designing things, building things, maintaining things, and even at doing jobs of installing things at somebody's home, right? So, but with computer science, it is more of programming was a mandatory requirement with detailed expertise, which is more of knowledge driven. But AI, or the new automation of knowledge, that's what I said, with an automation of knowledge, which is called a machine learning. So you have correct data, you place that automation engine into the context, the data getting converted into knowledge, and that knowledge you may be able to say, like, okay, you had, say for example, you have now new opportunities to look at massive data, massive genetic data of the country, and say like these kind of chemicals would be more good for these kind of people, which wouldn't have been happened, because our memory is more of the kind of data that our memory can process versus a computer's way of generating knowledge, right? And we have the right set of tools. The automation of knowledge discovery is in place, which means that from huge collections of data with the consumable libraries and capabilities in place, we can create a new age of workers, knowledge workers, which goes beyond the conventional click and do jobs. they can give data, proper clean data to the context, and the knowledge worker and the algorithms will find out they should only be able to interpret and go beyond whatever. It can even be a doctor trying to doctor working with a what you call pharma person trying to find out a new way of what you call a drug discovery process, right? Which the doctor has, may not have that opportunity in the past because he was more of a what you call a clinical person, and the other person was more of a chemical person. But these two people connected over an AI framework or data discovery leveraged by enabled by an AI framework would be able to reposition their skill to altogether different level. So skilling on the automated discovery engines, which are open source world, and we will find new ways of new functional areas and domains where you'll have employment. That's what I want to say.
Thank you very much. I appreciate it.
Okay, Sumaya, you can take over. Sumaya?
Yes, sir. Yes, sir. Thank you, sir. Thank you very much for those words of wisdom. Now, the next question is, consider AI machines developed in different countries with different cultures. Will they all give the same ethical decision for a given situation? How can they handle misinformation and wrong data?
Yeah, very interesting question. My answer is no. They'll behave like enough, and that's why I said contextualization and is very relevant in the case of deployment. And we need to contextualize any model. Say, for example, we live in an era of transferable knowledge, meaning things of the kind transfer learning. But transfer learning again needs fine-tuning to the context. Ethically, what works probably in an Indian context may not be may not be even the kind of, say, for example, you are building a boat. A chatbot which interacts with the customers in a banking context, and the same type of language if used in a different culture, you will end up in trouble. So it's as simple as that. Basically, no, you have to have fine tuning and the ethical dimensions and the societal acceptance and the parameters of those those dimensions will be different in different cultural contexts. That's my answer.
Thank you, sir. The next question is, how can we prevent the misuse of AI by some rogue nations for terrorism and them attacking other nations?
Yeah, that's more of a policy framework and deployment framework. It's basically like, the regulators have to come out with the right policy so that, currently, AI is more of performance driven, and the moment we build AI, which is more of explanation driven, and this explanation becomes transparent for consumption, which means that when an AI takes a decision or that decision being tweeted out to millions of people out there, right, and the explanation is also already there, you can actually build context, political context where this is preventable, provided the systems are transparent and the regulations are in place.
Thank you, sir. The next question would be, are engineering standards institutions addressing development of some standards for practicing responsible AI? Can this eventually help countries to bring in statutory framework for development of AI? Will the Data Security Act proposed in India impact AI development or incorporate guidelines for AI?
The answer is yes. So I've gone through the the PDB, the Personal Data Protection Bill, and for that matter, GDPR, primarily in practical context when it comes to the Indian data related issues. And so my experience is, I think Article 22 of the GDPR. I may not be correct. I think Article 22 of the GDPR is talking about right for explanation. That's what it is. 22 of the GDPR. GDPR is considered to be the primary document over which even our PDB has adopted principles from. Right to explanation becomes a mandated condition. So data and the way in which data being used, the way in which data-driven decisions are, or model, or the algorithms which build data-driven decisions are built. The GDPR or the PDP talks about those dimensions. Yes, when it comes to data and data intelligence, these regulations are definitely valid and are imposing on those explainability dimension.
So my
Yes, sir. Sir, I think you're muted, sir. Sir, you're muted.
sorry. The remaining questions will be answered because we are running too late. We have to leave the platform soon. Some other program is on the anvil, so we have to wind it up soon. So the questions will be collected and sent to the speaker, and the answer collected and sent to you. Please send your email ID to me so that I can post the question answer to you. Thank you very much. Now, Gifty, you can take over the other program, the vote of thanks. Please do it. Gifty. Yeah. Jacob, please unmute her. Jacob, please unmute her. Jacob.
Hello, am I audible?
Yeah. Please go ahead.
Okay. A very warm good evening to one and all present here. Today, we had a very wonderful and informative talk session on the ethics in artificial intelligence, a practitioner's perspective by very renowned and experienced speaker, Dr. Ashraf, Dean of Digital University Kerala, as well as the co-founder and professor in charge at Kerala Blockchain Academy. It was really an informative session on AI, and everyone could clarify all their doubts regarding AI. Also, many have posted their gratitude in the chat box too. So thank you, sir. Thank you for joining us and sharing your valuable time with us. I would also like to extend my sincere gratitude to Saifur Rahman, sir, for joining us. I'd also like to thank all the participants present here, as they are the one who made this event so special. I'd like to extend my heartfelt gratitude to Harindra Lal sir and all the other organizers behind the Inter-Society Weekly Webinar Series for arranging such an informative session. Thank you all. Also, we'd like to present a memento as a token of love from our part. Thank you, Dr. Ashraf, sir. So once again, thank you all for joining the 72nd talk session of Inter-Society Weekly Webinar Series. Thank you.
Thank you, Gifty. Once again, I would like to extend my sincere gratitude to our honorable chief guest for taking his precious time out of his busy schedule to be here and for sharing with us your valuable ideas and thoughts on this important topic. Thank you so much, sir. Now, I would like to inform you all about our 73rd talk, LT Line Snapping, Issues and Solutions by Dr. Krishna Kumar M. from Kerala State Electricity Board Limited, Trivandrum, which is to be conducted on next Wednesday, September 1, from 6 to 7 p.m. Hope to see you all next Wednesday. Thus, we have come to the end of today's session. Thank you all. Meeting is now officially dispersed.
Thank you all the participants, especially the speaker and Professor Saifur Rahman and other eminent participants for today. And thanks all the role players. Please attend the next program. Thank you very much. Thank you for the support. And we expect the continued support from all of you for the successful conduct of this program. Thank you very much. Afnan. Afnan, you can close the program.
Yes, sir.